Hey you guys, this is 3.8b, which is slopes of perpendicular lines, and it's going to look a lot like the 3.8a lesson, but with a slight twist to it. And here's the twist. If two lines are perpendicular, then their slopes, instead of being the same slope, their slopes are opposite reciprocals. Okay, what that means is you change the sign, okay, positive to negative or negative to positive, and you flip your fraction, okay? So if I have, for instance, a slope of 2/5, okay, the opposite reciprocal of that is negative 5/2, right? So it was positive and I made it negative, it was 2/5 and I flipped it over, okay? So these would be perpendicular slopes. Same thing if I were to give you a number like -3, okay? -3, the opposite reciprocal, it's negative right now, we'd make it positive, and then we'd flip it. Well, -3 is like 3/1, so this would be a positive 1/3. Okay, so these two are also perpendicular slopes, okay? The other way you can think of it is if you were to multiply the two slopes together, their product would be -1. So if I were to multiply those together, I would get -1. If that makes more sense to you, you may do it that way. That's kind of the way the book refers to it. I think opposite reciprocal is a little easier personally, but that is totally up to you. And then other thing to note, a vertical line and a horizontal line will always be perpendicular. So perpendicular, opposite reciprocals, except for a vertical line has no slope, it's undefined. So you can't say 0 and undefined are opposite reciprocals. Okay, so here's what you're gonna do with this. You're gonna be given two lines. So line 1 has an x1, y1, and an x2, y2. Okay, if they ask you to plot it, then you just plot those. -1, 2, 3, 4, 1, 2 would be here, and 0, -4 would be here. And then you'll draw that line in. Okay, so that's one line. And then the other line, we'll pick a different color here. You'll have x1, y1, and x2, y2. Okay, so we have these two different lines. We plot both of their sets of points. So -5, -3 would go here, and 4, 3 would go here. So it looks like that. Now, here you have options, okay? We want to know if the lines are perpendicular. And the way that you tell if lines are perpendicular is you check their slopes. So you could plug this into y2 minus y1 over x2 minus x1 and find the slope that way. And that's what I'm going to show you on the next problem. But I do just want to show you that there is a quick way to do this when you have a graph. I could just take the 2 points and I could do my rise over my run. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So up 6 over 9 is a slope of 6 over 9, excuse me, which would reduce to 2/3. Okay, and then if I do my other line, remember you always work left to right, so I would start at this point up here. And I would go 1, 2, 3, 4, 5, 6 down, and 1, 2, 3, 4 over. So a -6 over 4. If we divide by 2, we get a -3 over 2. So we have these two values as the slopes of our lines. And the question is, are they perpendicular? Well, either you multiply them together and see if you get -1, which you do, or you can just look at them and say, yes, those are opposite reciprocals. One's positive, one's negative. They flipped over. So yes, these are perpendicular. Okay. So if you have the graph, or if they ask you to graph, you're welcome to do it that way. If you don't have the graph, then you should do it this way. Let's say we have x1, y1, and x2, y2. Okay, so you're given line 1 goes through those 2 points. Line 2 goes through these 2 points. And we want to know, are they perpendicular? Well, to tell if they're perpendicular, we need to see their slope. So what we're going to do is we are going to plug both of these into slope formula. So again, like I said, y2 minus y1 over x2 minus x1. So it's going to be -1 minus 7 over 3 minus 2. And I get -8 over 1. Okay, so that's one of my slopes. And then we do the same thing with the other slope. 7 minus 6 over 8 minus -2. So that is 1 over 10. Okay, and if you look at these two, they are opposites, but they are not reciprocals. So you have an 8 on top and a 10 on bottom. So are they perpendicular? Your answer would be no, because they're not opposite reciprocals. Okay. Okay, so then your next thing that you're going to have to do is they're going to ask you to write an equation for a line that's perpendicular. And in the last lesson, in 3A, we wrote an equation for a line that was parallel. This is exactly the same thing with one extra step. Now, instead of being parallel, so if it was parallel, right, we would have said, okay, well then the slope should be 1/5. Well, in this one, it's perpendicular. So our slope, our perpendicular slope, should be the opposite reciprocal. So if it was 1/5, we're going to turn that 1/5 into a -5 over 1, which we can just call -5. Okay, so we're going to take that new slope with this point, x1, y1, and we'll plug that into point slope form. Okay, so we're going to take these numbers and just drop them in. So y minus a -4 equals a -5, that's our m, times x minus 15, which is our x1. So simplified, this would just be y plus 4 equals -5 times x minus 15. Okay. Maybe pause me and you try this next one on your own, and then I'm going to do it for you right now. It says, what is the equation of the line perpendicular to y equals x plus 3 that contains the point -4, -1? So we're going to call this our x1, y1. And then we need to figure out what our slope is. Right now, the slope in this line is 1, right? It's as if there's a 1 out here. So my perpendicular slope has to be the opposite, so negative because it was positive, and then the reciprocal. And 1 over 1 flipped is 1 over 1. So we're going to be working with a slope of -1. So it will be y minus a -1, so y plus 1 equals -1 times x minus a -4. So minus a negative is plus a positive 4. And that will be your answer. Excuse me. Okay, then last example. It says the baseball field below is on a coordinate grid with home plate at the origin. Okay, so 0, 0 is home plate. A batter hits a ground ball along the line show. The player at 110, 70, so that's that blue point now that I just colored in, runs along a path perpendicular to the path of the ball. What is an equation of the line on which the player runs? So basically what they're saying is this line right here, let's see if I can extend this a little. Okay, this line is going to go perpendicular to a line this way. Okay, and we're trying to figure out what is the equation of this line that the player will run at. So what we're going to do with that is we are going to take the slope of this first line. So we're at 0, 0. It looks like it hits perfectly again right here. Okay, now here's the nice thing, you guys. You could plug those 2 points into slope formula, but because it looks like they're counting by tens on both sides, it's going to reduce to whatever your count is just by looking at it. So this is up 1, over 3, right? So my slope is 1 over 3 for this line. We want the line perpendicular to that goes through the point 110, 70. Okay, so my perpendicular slope is going to be to take the opposite reciprocal of 1/3. So opposite is going to make it negative, reciprocal is going to make it 3. And then we have these 2 points, or these 2 values, x1 and y1, that make our point. So we're going to say y minus y1, 70, equals -3 times x minus x1, which is 110. And they're looking for the equation of the line. That would be it. That is the equation in point slope form. Okay, so very similar to 3/8a, you just have opposite reciprocal to think of first. Have a good weekend.